Jess, you look like you just saw a ghost. What has you so scared?
I saw something else. I just saw so much worse.
Well, what was it? What did you see?
I just opened my math curriculum for this year, and it was the most terrifying thing I've ever seen. How am I supposed to teach my students all this stuff? There's so many different topics and concepts that my students are expected to know. How am I supposed to teach them all of that?
Oh, I'm sorry to hear that. That sounds awful. But I remember I was terrified to teach math too. Hey, what if I told you I had a way to make math seem less scary? What if I said I could make teaching math seem like a fairy tale?
Well, then I would have to say I wouldn't believe it until I see it.
Well, then you just sit tight because I'm about to show you a math manipulative that is going to make you a lot less afraid of teaching math.
Now, these pattern blocks are really something I could get behind. Would you mind telling me more about them?
I would love to. Let's start with the basics. Pattern blocks are an assortment of 6 shapes in 6 colors. There's green triangles, orange squares, blue parallelograms, tan rhombuses, red trapezoids, and yellow hexagons. The shapes are designed so the sides are all the same length except for the trapezoid, which has one side that is twice as long. This feature makes it possible for the shapes to nest together and provides for a wide range of explorations. They are useful for so many different mathematical applications beyond their namesake.
Before we continue, I'm going to go out and grab something. I can already tell how much I'm going to love using pattern blocks, so I went and got myself some. I'm going to follow along with them while you continue to talk about them.
That was so speedy, quick. Pattern blocks can be used to support and assess students in 131 different specific expectations set out by the Ontario Math Curriculum, including composing and decomposing shapes. So as I mentioned earlier, these blocks are created in a way that they are representative of each other. The green triangle can be put together to create the parallelogram, trapezoids, and hexagons, and they have the same side length as the rhombus and square. There are so many configurations to compose shapes out of others and to decompose the larger shapes into smaller and smaller shapes. It's a great introduction to fractions and the association with the whole number. You can also use them for symmetry. One can use the individual blocks and analyze the symmetry. Each of the pattern blocks have at least one line of symmetry to learn about. However, the more hands-on way is to create more complex symmetrical designs. Students can create objects such as snowflakes to further their understanding of symmetry. It's also a great way to begin to look at transformations. As I mentioned earlier, fractions, especially, these blocks are representative of each other and as such are also proportional to each other. The whole yellow hexagon can be created with 2 red trapezoids representing halves, 3 blue rhombuses representing thirds, and 6 green triangles representing sixths. Combinations of each of these shapes can be used to represent any combinations of fractions, creating a whole. Educators can use these blocks to reinforce knowledge following the creation of a paper fraction kit, or to introduce the students to the topic of fractions prior to the creation of a paper fraction kit. You can also use them for area and perimeter. Educators can use one of the blocks as a unit, and then use that to find the perimeter and area of the other pattern blocks. You can further this understanding by using these blocks to look at the relationship between area and perimeter, as well by comparing the set of blocks. They can also be used for algebraic ideas. While people assume patterning blocks are used mostly for younger students, they are great for older students as well. They are used in algebraic problems to help students visualize the relationship between numbers. Example below how students use pattern blocks to solve a problem called the trapezoid problem. This helped students identify the pattern in a single set of data rather than having to compare to different data sets of just numbers. And it just keeps going. There's so much more, including other algebraic ideas such as graphing, tessellations, or tiling, as well as other mathematical concepts of counting, equivalence, geometry, including three-dimensional shapes, spatial relationships, including negative space, and, of course, patterns and patterning.
It almost seems like these pattern blocks can be used for anything. It seems like pattern blocks are limitless. While you were talking about the fractions, I made some of my own.
Wow, see, the only limit is yours and the students' imaginations. Pattern blocks are also great for students young and old to simply play around with. There is so much potential in the power of play, and these tools can reinforce most types of mathematical learning. Students can create a large pattern using all of the blocks and discuss the area of the trapezoid being the area of three triangles. Students can create designs of animals or objects and see the relations amongst their creations. Pattern blocks are amazing learning tools.
I had no idea that these simple shapes could be utilized for so much in the classroom. For so many students and teachers like myself, math can be really intimidating. So it's great to know that there are tools out there, such as pattern blocks, that can help with a number of different kinds of math.
Pattern blocks are surprising. Educators sometimes do not see their potential and only use them in younger grades to create simple repetition patterns. But you should be able to teach a wide variety of subtopics and subjects in math using pattern blocks. The use of pattern blocks provides a perfect opportunity for authentic assessment. Watching students work with the blocks gives you a sense of how they approach a mathematical problem. Because these pattern blocks can be used for a number of different math units, they should always be made available for students. One of the biggest mistakes an educator can make with manipulatives is showing students exactly how to use them. If they are simply given and students are given the chance to explore and use them in this way, it's more useful to them. They will be much more likely to succeed and explore their own learning.
Wow, I'm not scared of teaching math at all anymore. Actually, I think I might be a little excited.
Perfect. Teaching math doesn't necessarily need to be scary. It can be daunting, sure, but pattern blocks are such great manipulatives that you needn't worry.
Well, thanks, Pollux, for helping me turn math from a horror story into a fairy tale. Now I'm going to take some time to explore my pattern blocks some more. And cake. Crushed it.